And we are live. Hey everybody, it's Wednesday and it feels like Groundhog's Day because we just keep doing this over and over again. Anyhow, one of the things I really want to emphasize to you, okay, really do, listen, if you are not doing your work and if you're not trying, then at the end of the year in June, I cannot pass you on. You must give an effort. So most of you are. All you got to do is just try. Most of you, awesome. There's a few of you that aren't doing your part, and you guys probably aren't even watching this video. You're probably just not doing anything. But anyway, those of you who are doing your part, good job, because we're going to pass with good grades. Anyway, moving on. This is what we're going to talk about today. So first of all, homework answers from last night. Section 6.3. After I solved for x and plugged it in, I got nf equals 1. 2, after I solved for x and plugged it in, I got NGS 4. Same thing, I got 7 for NM. On 4, PA is 13, right? That seems obvious. PS is 8, that seems obvious. GE is 10, that seems obvious too. And 2NF is 2, that seems pretty obvious there. Okay, now on these you had to graph it. When you graphed it, you were looking for the perpendicular bisector, so perpendicular bisector here, here, and here, and I wind up with the point 2,1. Perpendicular bisector here, here, and here, and I wind up with the point at 6,3. And perpendicular bisectors here, here, and here, and I wind up at the point at -1, -5. Okay, so those are our homework answers. Please show work, okay? Now, moving on in today's notes. Okay, so I did a little bit of work. Normally, we would have done this in class, and I would have had you do these constructions, but we just can't. We just don't have the resources to do that. So, today, let's talk about a couple of things. This is what we did yesterday, a perpendicular bisector, okay? I want you to see the difference between an altitude and the perpendicular bisector. An altitude is actually from the angle itself, straight down, okay? It does not cut the other sides in half. Perpendicular bisector does, but a perpendicular bisector does not go through the angle. Okay, everybody see the difference? Not equal goes through the angle. Equal does not go through the angle. Perpendicular, perpendicular. Okay, that's an altitude, which kind of altitude is like the height of the triangle. Well, straight down, right? We're also going to talk today about something with the angles. Okay, now angle bisector cuts it in half. The angle cuts the angle in half. 35 degrees. I measured it with my protractor, but I used my ruler. These two sides are not equal, okay? 4.4 centimeters, I just measured. These are not equal, but the angles are equal, okay? It's an angle bisector, and we found the end center from that. Now, today we're going to talk about a median. What is a median? It's from the angle straight across to the middle. This is the midpoint. So it cuts it in half, but it does not cut the angle in half. You see that? For the end center of the angle bisector, it cuts the angle in half. The median just goes straight from the angle, straight across. If you did it from here, it'd probably go right about there. It does not cut the angle in half. I want you to see that, okay? So today, we're going to draw altitudes, and we're going to make a thing called the orthocenter. We're going to draw medians, and we're going to make a thing called the centroid, okay? So, let's take a look at that. So first of all, we would have done this in class, but we can't because, you know, here we are. So I drew a triangle, and I would have given this to you, and I would have had you then find the medians. Now the medians, okay, so I measured this using my ruler, and this whole thing was 12, so I cut it in half. 6 and 6, found the midpoint, okay, let's call that x, just for the heck of it, okay? Then I drew from the angle straight down to x, which is the middle point, okay? Here's my ruler, measured straight across, got this to be what, 9.6, cut in half, so it's 4.8, 4.8, drew from the angle, straight across, and I got what we call the median, okay, the median goes to the middle, okay, let's call that y, okay, and then I did the same thing here, measured that, obviously it's 11, 5.5, 4.5, so then I found the median, which is the middle, let's call that z, okay, now this becomes the point of intersection. That's called the centroid. Let's call that C for centroid, okay? What we'll learn in today's lesson is that when we get the centroid, it divides things into thirds. Let me give you an example, okay? If this side were, say, oh, let's say 4, then this side would have to be 8. If this side were hypothetically, oh, let's say it would be 3, then this side would be 6. See how it cuts into thirds? If this side were, say, hypothetically, I don't know, I'd make up a number, 2.5, then this side would be 10. Nope, 5. Golly. 2.5, 2.5. Okay, anyway, we're going to learn that in today's notes. Now, the other one we're going to talk about, okay, that's the centroid. This thing called the orthocenter, okay? That's the altitudes. I did a little drawing for you again. The altitudes are from the angle straight down 90. Okay? Turn it that way. From the angle straight down 90. Okay? It does not cut it in half at all. And from the angle straight down 90. Does not cut it in half. Okay? This is not a perpendicular bisector, but it goes from the angle. Okay? So then they all intersect in a thing called the orthocenter. Okay? That's the point right there. Call it P is the orthocenter. Now there's nothing really special about the orthocenter, so that's okay. However, if we have an obtuse triangle, you can see you have to extend. Here's my obtuse triangle, greater than 90. To extend your line out, and then to get 90 is straight down. You get 90 degrees here. Altitude, how tall is the triangle? And the same thing here. Okay, this one's easy because it's just, this one's really easy because it's just straight down 90. And then that gets you here. And then finally, on this last one, again, you had to take and extend the line out to get its altitude. And what happens if you have an obtuse triangle is the orthocenter is outside the triangle. Okay? You'll see that in today's homework. Now, moving on. So what's the big deal? So let's take a look at the notes so you know how to do it. Okay? So today's notes, what we're going to talk about is our centroids, which comes from the intersection of medians, and our orthocenter, which comes from the intersection of altitudes. Okay. Alright, so let's see. Median. Okay, median is just from the angle to the midpoint. Okay. And so we did that. I'll show you. Okay. Here's a median. From the angle to the midpoint, and we can draw a picture of that again if you want to. Okay, so if I did that, if I just drew a picture, try not to draw an isosceles or an equilateral triangle because it just, there's too many things that happen. Okay, so the midpoint, I can just measure it, and if I just measure this, see it's about 3 point maybe 8. Okay, so half of 3.8, 19, 1.9 is right about there. And so if I draw it from the angle, median, okay, if I want a median from the midpoint, okay, so it's right straight there to the midpoint, okay, boom, that's a median. This side is equal to this side, but the angles are not equal. Okay, that's a median. Now, the centroid, of course, is going to be the intersection. Centroid is the intersection of all 3 medians. Okay, so we did that. Did that construction. Okay. Drew them, medians. I got a central point called the centroid. Okay, now, what's the big deal? Well, the big deal is it actually cuts it into, I call it thirds, okay? Now, when I call thirds, I'll show you why, okay? So if I take this whole thing here, let's take Qn versus 18. Qn, if Qn is 18, let's divide that into thirds. So 18, I divide that into thirds, and I get 6, okay, into thirds. So Qn, if Qn is divided into thirds, okay, watch this, then I've got 1 piece, 2 pieces, and 3 pieces. How it works, okay? So that means this has got to be 6, this be 6, and this is be 6 also. So what I know is that I could say that QP is 6, and PN is 6, and 6 is 12. Or some of you are saying, well, gosh, Mr. Stevenson, the same thing, is this twice as big as this? Yes. Okay. So then if NP is 12 and I divide it into thirds, right, that means this is going to be 6 and that's going to be 6, and this is also going to be 6. So we can say that MS, the length of MS all the way across, is 18. And we could say that SP is 6. Okay. Now, if this is 5 on LR, and that means this would be 5, and this is also 5. So we could say that LR, the whole LR, would be 5 and 5 and 5 is 15. And we could say that LP is 5 and 5 is 10. Okay? So, one way to look at it, yes, is that in centroid the short piece is going to be half as big, or we could say the longer piece is twice as big. For me, I've always thought if you just divide the whole thing to thirds, then it makes it pretty easy to see. Okay, that's the centroid, and that'll be part of your homework today. Okay, so let's go ahead and turn the page. Let's talk about the next one, which is our orthocenter. Okay, so the orthocenter comes from the altitude, and the altitude is simply a line segment from an angle perpendicular to the opposite side. Okay, and we did that. So, well, I did it. So here's an altitude, right? Straight down. It's kind of like the height of it. So again, if you want to draw a picture off to the side, you can. You can draw another picture if you want to, but let's see. Don't draw an equilateral triangle. It just doesn't work very well. Or an isosceles triangle. It doesn't really show much because everything's equal if you do that. Okay, and straight down 90. They call it the altitude because it's the height of the triangle, isn't it? And on an obtuse triangle, the altitude is outside of it. So let me draw that one also. If you draw an obtuse triangle, then to get the height of the triangle, you would measure straight down, right? If you want the height of the triangle, so you'd measure straight down. Right, if you want the height of this, you would measure straight down. How tall is this triangle? It's outside the triangle. The altitude is right there. Okay. Alright, so the orthocenter then is the intersection. The orthocenter is the intersection of all 3 altitudes. Okay. Alright, so let's do example 2. Alright, let's actually graph triangle ABC and find the orthocenter. Okay, so -2, -1. There's A. 1, 2, 3, 4, 5, 6, 7, 8. There's B. 1, 2, 3, 4, -1, there's C. Okay, let me draw my triangle in. And draw my triangle in. Okay. Now, let's see. Let's find the easy one first. The easy altitude is from B, straight down. And it's easy because it's on graph paper, and my lines in my graph make it easy to get straight down. Okay, so I'm going to draw that one in first. Okay, so I'll put that one in first. It's going to look like that. Here's my first altitude. Now the second one's a little bit harder, but what I know about this is that perpendicular lines, because I need perpendicular, because I'm looking for altitudes, okay? Perpendicular lines have opposite slope, right? Well, let's think about this. So slope of this line is down 3 over 1, down 3 over 1, down 3 over 1. So from this point, from point A, instead of going down 3 over 1, we're going to go up 1 over 3. Now watch how I do this. Up 1 over 3, up 1 over 3, and there is my altitude. So I took the opposite slope. If you didn't see that, I'll show it one more time. Okay. So the slope of its opposite line from A is down 3 over 1, down 3 over 1, down 3 over 1. So the opposite slope from A would be up 1 over 3, and that makes these two perpendicular. Okay, now I pretty much have found my other point, but let's go ahead and take a look at it, okay? So from point C, we want to draw the altitude, but let's see what this slope is. This slope is up 1, 2, 3 over 1, up 3 over 1. So the opposite would be to go down 3 over 1, but we're going to do the opposite direction, so we're going to go 1, 1, 2, 3, 1, 1, 2, 3, and we wind up getting the opposite slope, which makes it perpendicular on this side. There's my point right there. Okay, now let's take a look at the homework. Okay, so the homework is going to be on page 205, 1 through 11 all. Okay, so let's take a look at it so you know what we're doing. Okay, I'm going to go to page 205. Page 205. Okay, so these first, you're just going to find PN and QP, and they're going to give you information to find them. Remember this, breaking it into thirds, or this is twice as big as that. Okay. Same thing over here. Centroid, so again, it's a centroid, so you've got break it into thirds. Now on 6, you're going to graph it and find the centroid. On 9, 10, 11, you don't have to find the centroid, you just have to, or the orthocenter, I'm sorry, the orthocenter. You don't have to find the orthocenter, you just have to find out whether or not it's inside, or, oh no, you didn't need to find it, sorry. So you got to find the orthocenter. Okay, anyway, have fun with that, and we'll talk tomorrow. Please keep sending you my work. If you don't send my work, send work to me, then, you know, it could be a real bummer thing.